If you've heard me speak before, or you remember your secondary school biology, then you're already familiar with this guy, the mitochondrion. Mitochondria exist inside the cells that make up our body and provide us with the vast majority of energy that we need to function. But mitochondria are so much more than just the cell's power generators. In fact, one of their most important jobs is to prevent us from getting cancer. Now, cancer begins when one cell among trillions malfunctions and begins to divide uncontrollably. Internal checkpoints within the cell can sometimes tell the cell to stop dividing, or if that fails, to destroy it. That's where our mitochondria take on their most dire role, to initiate cell death. Throughout our body, cells are constantly being created and destroyed, so the loss of any particular cell, especially one that's about to become cancerous, is actually quite beneficial. When our mitochondria sense that a cell is about to become cancerous, they leap into action and open up their membrane using the molecular machines of the cell called proteins. And from their insides, they unleash a special type of protein called cytochrome C that causes the cell to swiftly self-destruct and stop becoming cancerous. So, if our mitochondria have this extreme method to stop us from getting cancer, then why do we still get cancer? Unfortunately, cancer has ways of shutting off this mechanism, stopping the release of cytochrome C, and preventing our mitochondria from destroying cancerous cells. So if we want to figure out how we can help our mitochondria to prevent us from getting cancer, we have to figure out how our mitochondria open themselves up and release the cytochrome C protein, a process that we know is carried out by another protein called BAX. Now, we've known for quite a few years that BAX is responsible for opening up the mitochondrial membrane, but we just don't know how it does it. I'm using a new method of microscopy to look at both the mitochondria and cellular proteins like BAX in great detail. I do this by making BAX fluorescent and then seeing where in the cell BAX is and where it goes to on the mitochondria. I then use a more powerful microscope to zoom in on that exact location and take an electron microscopy image to see the structure of the mitochondria in great detail and how BAX is causing it to open up. Our hypothesis is that many BAX proteins might go to a single spot on the mitochondria and allow a pore to open up through which cytochrome C can pass through. If we can figure out how BAX normally does this, we can figure out how to help it during cancer, in which it might be turned off and we can reactivate it. Thank you.